Welcome everyone. My name is Fatim and I'm honored to represent our team HackOps. Today, we're excited to present our project which aims to revolutionize the way UIDAI handles bot detection on its platform. We understand the frustration many users face when interacting with traditional CAPTCHA systems, and we've developed a solution that only improves security but also enhances the user experience. Our approach leverages the power of AI and machine learning to create a seamless passive bot detection system. But before diving into the technical details, let's take a moment to understand why this project is so crucial. Let's begin by addressing a common frustration: CAPTCHAs. How many times we've all been stopped in our tracks by those annoying click the traffic light or type the letters challenges? They're meant to keep bots out of line, but they often end up frustrating legitimate users. To illustrate this, let's visit the UIDAI website. Here, you can see the traditional CAPTCHA in action. It's clear that while it serves a purpose, it also creates unnecessary friction. Users often struggle to identify the correct images, leading to repeated attempts and unfortunately a poor user experience. This isn't just an inconvenience, it's a barrier that can discourage users from completing their tasks, which is particularly problematic for a service as critical as UIDAI. Our goal is to remove this friction while maintaining and even enhancing security. CAPTCHAs also pose accessibility challenges. For users with disabilities, these tests can even more be frustrating, sometimes rendering online services unusable. Moreover, CAPTCHAs are not foolproof. Advanced bots are increasingly capable of bypassing these checks. This is where a solution comes in, an approach that is not more secure but invisible to the end user. For the technical implementation of a solution, we are leveraging two advanced machine learning models: LSTM, long short term memory networks, and random forest classifiers. Let's break down how each of these works within our system. LSTM model. LSTM is a type of recurrent neural network that excels at analyzing sequential data over time. In our context, it is used to monitor, analyze user interactions on their website. These interactions include environmental parameters like mouse movements, keystrokes, device type, IP address, and reaction times. Since there is no existing data set for this specific application, we have designed our own. We've done this by simulating interactions on a replica site to collect data from both human users and bots. This dataset is then used to train our LSTM model, allowing it to learn subtle patterns that differentiate legitimate users from the bots. The model continuously processes this data in real time, providing a robust layer of bot detection. Random forest classifier. If the LSTM model flags any suspicious activity that indicate bot behavior, our system triggers a secondary layer of detection using random forest classifier. The random forest classifier is particularly suited for this task due to its ability to handle complex nonlinear data relationships. Here's how it works. When a user is flagged, they are represented with a simple task on a white canvas, completing an incomplete shape. This task is difficult for bots to perform correctly. The data from this interaction, such as how the user moves their cursor to complete the shape, is then fed into random forest model. This model analyzes the user's behavior and provides a final decision on whether the user is a human or a bot. Since we didn't have any pre-existing dataset tailored to our needs, we created a custom dataset by simulating both human and bot interactions. This involved collected data process is crucial because the accuracy of a bot detection system depends on how well the model can distinguish between these two entities. Integration and compliance. Our system is designed to integrate seamlessly into UIDAI's existing infrastructure with minimal changes. The use of modern web technologies like HTML, CSS, JavaScript, and Python allows users to capture the necessary environmental parameters and feed them into our machine learning models. All data captured is encrypted and handled in compliance with UIDAI's privacy and security guidelines, ensuring that user data remains protected at all times. Adaptive learning. One of the strengths of our approach is that its adaptability. The LSTM model, in particular, is designed to continuously learn from new data, allowing it to stay updated with evolving bot tactics. This reduces the need for frequent manual updates and ensures that our system remains effective over time. Additionally, by only triggering the secondary random forest check when suspicious behavior is detected, we minimize the user interaction, preserving a smooth and uninterrupted user experience. Let me explain the secondary layer in more detail. Imagine you're a bot trying to mimic human behavior. You might be able to fake some things like clicking on a button or typing text, but certain tasks remain challenging. For example, completing a shape on a canvas, a task that requires understanding of concept, perception, and precise control, is something that a bot would struggle with. Our secondary layer uses random forest model to evaluate the user's response to this challenge. If the user is flagged as a potential bot by the LSTM model, they are presented with an incomplete shape on the whiteboard. This is what the user might see. They'll be asked to complete the shape. A human user would naturally follow the contours and complete the shape correctly, but a bot might draw erratically or fail to understand the task altogether. The data from this interaction is then fed into a random forest model, which makes the final determination on whether the user is a human or a bot. This two-layered approach ensures the bots are caught while legitimate users experience minimal disruptions. What's great about this is that the challenge only appears if suspicious activity is detected, meaning most users will never even know it's there. This preserves the user's experience while adding an extra layer of security. Security and privacy are, of course, top priorities of UIDAI, and we've designed a solution with these concerns at the forefront. Our system adheres strictly to the UIDAI's privacy policies, ensuring that all data collected, whether it's mouse movements, keystrokes, or the user's interaction with the shape completion task, is handled securely and in compliance with relevant regulations. All captured data is encrypted and stored in a way that maintains users' anonymity and confidentiality. We've also ensured that our solution integrates seamlessly with UIDAI's existing infrastructure, requiring minimal changes to the current system. Our passive detection system is not just effective but also ethical. We are not collecting any personally identifiable information. We are fully compliant and with data protection regulations. By focusing on environmental parameters and user interactions, we can achieve high levels of security without compromising user privacy. In conclusion, our solution offers a secure, user-friendly, and scalable alternative to traditional CAPTCHA system. By leveraging and by leveraging AI and machine learning, we've created a passive fraud detection system that operates behind the scenes, reducing user frustration and improving accessibility. Our two-layered approach ensures that bots are caught while legitimate users enjoy a smooth and uninterrupted learning experience. Most importantly, We've designed a system to align with UIDAI's stringent privacy and security guidelines, ensuring that it is not only effective but also compliant and ethical. Thank you for your attention. We are confident that our solution can make significant impact on the UIDAI platform. We are excited to discuss any questions you may have. Thank you.